you do? Tell me. Someone try. We are looking at B point 2.1. What are the inlet conditions? 1500 kilopascal, 35 degrees Celsius at the inlet. So what is the enthalpy? Check the table. Check the table. B point 2.1. This is for saturated ammonia. You are given that inlet 1500 kilopascal. I'm already converting megapascal to kilopascal, right? And temperature is 35 C. How will you find the enthalpy? What's your thought? Anyone? Right. So if you are looking at the table for enthalpy B point 2.1, you see that 35 degrees Celsius. Okay, 35 Celsius. Pressure is given to be 1350. But what is the pressure given in the problem? 1500. So what's happening here? My answer to that is this is not the data in the problem is not quite correct, because your pressure is 1350.4 and temperature is 35, but what is given in the problem is 35 degrees Celsius and 1500 kilopascal. That means there is a mismatch in either the temperature or the pressure. In other words, I think the correct data should be somewhere between 35 and 40 temperature. That will give you a pressure of 1500 kilopascal. Okay, so he has approximately taken the HF value for 35C, which is 346.8, right? That is the saturated liquid value. Why liquid? Because you have liquid ammonia. State is a liquid. Okay, you are assuming that you have a saturated liquid. That's why you're using this table. So he's taking 346.8 as the inlet enthalpy, kilojoule per kilogram. Okay, but there is a clear mismatch in the data according to me, because 35 degrees Celsius does not have a pressure of 1500 kilopascal. 1500 is somewhere between 35 and 40. So anyway, that's what it does. What about the outlet? That is the same as the inlet, right? Now, sorry, what is the outlet? How will you find out the outlet case? See, in the outlet condition, what is given? 291 kilopascal pressure. Now you will get confused, because this table for ammonia is only one table. What is the table? The first entry is temperature column, second column is pressure. So you will go ahead and start searching for the reverse table, right? Where the first entry is pressure and the second entry is temperature, but it is not given to you. The next table is superheated straight away. Superheated ammonia, B point 2.2. So unlike water, where you are given conveniently two tables, B point 1.1 and B point 1.2. No, there was a temperature pressure table and a pressure temperature table. That is not given here in ammonia. What you are expected to do then is use the same table. Okay, look, outlet pressure is 291 kilopascal. So look at the second column and find where is 291. You find that 291 at minus 10 C, 290.9. Do you see that? And I told you that the final temperature will be lower because it's the freezer section. As I said, it's minus 10 C. That makes sense. Okay, is that clear? So you can now use that value for you can use that entry for the enthalpy. Okay, which entry? Your HF and HFG. I'm looking at the entry for minus 10 C Celsius because the pressure is 290.9, which is 291 kilopascal. I repeat, there is no separate table where the first entry is pressure and the second entry is temperature, unlike the case of water. There's only one table given to you. So you will have to use the same table, whether you are given T and asked for P or vice versa. Here you are given P, which is 291 kilopascal. That corresponds to a temperature of -10, right? So you can use this enthalpy values now, 134.41 and 1296.4 to calculate the quality. What you want is the quality. Quality for which value? For the HI value, 346.8. What is the outlet enthalpy? Same as inlet enthalpy. We're not interested in the outlet enthalpy. We're interested in the quality here. Because 346.8 is between 134.4 and 1296.4. Which value is given by X? How much, what fraction in between these values? So that's what you find X. So you find X as 0.16. So 16%, 16.38% is the quality for this liquid ammonia problem. Is this clear or not clear? You notice that there is a slight difference in the table here because there's only one table given to you, the TP table, but you have to use it also as the PT table. There is no extra table given to you, unfortunately, for in this book. Any questions, or we will stop and do more problems tomorrow. Two more at least before we move on. Okay, so which problems have I covered today? Please read it. 6.5, 6.6, 6.8 and 5.6. These ones I have covered today. 4 problems. I have I have one more problem to cover. I will do that tomorrow. Any questions, or we will stop? Okay, we'll continue tomorrow.
Thank you, sir. Bye, sir.